C++11 introduces unordered associative container. There are unordered set or multi-set, unordered map or multi-map. Just as the name indicates, the order of the elements are not defined, and they may change over the time. Internally, an unordered container is implemented with hash table, which is an array of linked lists. The array is also called array of buckets, and the linked lists are called entries. Each element is used by the hash function to calculate a value, and based on that value, the element is inserted into its own place in the entries. The biggest advantage of this kind of structure is if you have a fast and effective hash function, finding an element in the hash table is very fast. It only takes constant time, the fastest among all the containers. Here I created an unordered set of string which contains red, green, and blue. Then I use the member function of find to find the element of green. This takes amortized constant time, which is very fast. If the find function found the item, it will return an iterator that points to that item. Otherwise, it will return an iterator that points to the end of the container. So before you go ahead and dereference iter, it is very important that you to check if iter is pointing to the end, because dereferencing the end iterator results in undefined behavior. I can insert another item of yellow which also takes constant time. I can even use it together with other containers. Say I have a vector of string which has purple and pink. Then my set insert vec.begin, vec.end, which inserts every item in the vector into the unordered set. It's very convenient. Unordered set also provides some hash table specific APIs. Load factor function tells me the load factor of the hash table, which is the ratio of the total number of elements and the total number of buckets. Bucket function tells me which bucket the element of X is stored at. Bucket count tells me the total number of buckets. Unordered multiset is an unordered set that allows duplicate items. Unordered map is very similar to unordered set, except that each element is a pair of key and value. Unordered multimap is unordered map that allows duplicate keys. One thing you have to keep in mind is that although hash table provides amortized constant time searching, this performance might degrade because of hash collision. Hash collision means many items are inserted at the same buckets. So a degraded hash table may have majority of its items inserted only at a few buckets. The worst case looks like this. All the elements are inserted into one bucket. So the performance of searching has degraded from constant time to linear time. Properties of unordered containers. First, fastest search and insert at any place, which takes amortized constant time. Remember, the associative container takes guaranteed logarithmic time, and vector and DAG takes linear time. List takes constant time to insert, but it requires that you already have a pointer points to the position to insert. And the list takes linear time to search. For unordered set and multiset, the element value cannot be changed. For unordered map and multimap, the element key cannot be changed, because the change of this value will corrupt the data structure, the hash table. There is no separate container called associative array, but associative array can be implemented with map or unordered map. Here I created an unordered map of char and string, which has S Sunday, M Monday. Then accessing the value of each element is just like accessing a regular array. So day S is Sunday. This is why it is called associative array. The member function at provides the same thing, but it also provides range check. One thing to note is if I have a vector vec equal to 1, 2, 3, and then I do vec5 equal to 5, this code won't compile because vec5 is not created yet. However, for associative array, if I do day w equal to Wednesday, this will effectively insert the pair of w Wednesday into the container. So this is the same as calling the insert function with the pair. However, the insert function cannot be used to modify the existing elements in the container. So if I insert M Monday, since M Monday is already in there, this operation will fail. And the subscript operator can be used to modify the existing member. So this one will succeed. So the subscript operator provides a write access to the container. This has an important consequence. Say I have a function foo which takes an unordered map of m, and m is passed in as a const. And inside the foo function, I try to modify m by saying ms equal to Sunday. This code certainly will not compile because m is not modifiable. Suppose I only want to print out ms, so I don't need to modify it, I only need to print it. This code should compile since we are only doing a read on m, right? Wrong. As innocent as this code looks, it will fail with the exact same message as the previous one. So what happened? It turns out the subscript operator provides a write operation to the container. So when the compiler sees this, it will assume that you are going to write into m. So in order to print ms, we have to do auto iter equal to m.find s. This will find the element of s. And if, remember, very important, do the check. Iter not equal to m.end. Then print out iter. So this is the correct way to print out the element of s. Some notes about associative array. Associative array can be implemented either with unordered map or map. So which one should I use? For search time, unordered map can provide constant time search, and map provides logarithmic time search. So it looks like unordered map is better. But you need to be aware that unordered map may degrade to linear time search. However, map provides a guaranteed logarithmic time search. So this is actually important for real-time system. So these are the things that you need to think about before you choose which one to use. Another note is you can't use multimap or unordered multimap to implement associative array because they don't have unique keys, and they don't even have subscript operator. STL also provides 3 container adapters. Container adapters are implemented with fundamental container classes. They provide a restricted interface to meet some special needs. First one is a stack. Stack provides push, pop, and top. Top allows you to peek at the element on the top. Queue is a FIFO. It provides push to push element in the front, pop an item at the end, front and back. priority queue is a queue of items of different priorities. The only guarantee is the first item always has the highest priority. So priority queue has push, pop, and top. There is another way of categorizing the containers. Array-based containers, which include vector and deck. Node-based containers include list, associative containers, and unordered containers. The importance of this is you should always keep in mind that array-based containers invalidates pointers. The pointers includes native pointers, iterators, and references. For example, I have a vector of integer vec which has 1, 2, 3, 4. And I have an integer pointer p which points to vec2. Naturally, p points to 3. Now I insert another item of 0 at the beginning of vec. Then I print out the content of p. What will be printed out? If you are lucky, it print out 2, because that could be the new location of 2. If you are unlucky, however, it will print out a random number. If you are really unlucky, or I should say if you are lucky, the program will crash. In summary, this results in undefined behavior. Every time you remove something from a vector or insert something into a vector, the pointers that previously pointing to the content of the vector might get invalidated. Sometimes they are not, sometimes they are. But it is dangerous to assume those pointers are still valid. So in this case, we should stop using the pointer p anymore because of the insertion. But the node-based container doesn't have that problem. Their pointers will remain valid even after you have inserted something or removed something from the container, as long as the pointee is not deleted. That's all for today. Thank you for watching. Feel free to subscribe to my channel so when I post a new video, you will be updated. Or you can go to my channel's homepage and see what I'm offering today. Bye bye.